we're going to fill it in, and we're going to get -4/5 squared plus y squared equals 1. -4/5 squared is 16/25 plus y squared equals 1. Subtract that over, so y squared equals 1 minus 16/25. 1 is just 25/25, so 25 minus 16 is 7. No, it's not. 9. Okay, over 25. Oh, it's going to work out so much nicer than my stupid 7 that I don't even work out that. That's really good. Okay, so 9/25, this is way better because what do we have to do to get y by itself? Square root it. And when we square root 9 and 25, what do we get? 3/5, which makes life a lot better than what I was saying. So remember when we square root, we have to take the what? Plus or minus. So y equals plus or minus 3/5. Now, if they gave you no specifications other than that was the coordinate, you'd have two answers, right? It would happen in two spots, correct? This part on the unit circle, so you could have x is negative in quadrants 2 and 3. So you would have a point here and you'd have a point here, correct? But it specifies that it can't be in both quadrants. It actually says it has to be in quadrant 2. So what's your y going to have to be? Positive 3/5. Okay? And we're going to go down to example 7. So literally on the unit circle means you just plug it into x squared plus y squared equals 1 and solve for it. That's it. If it didn't tell me the quadrant, I'd have 2 points, right? 2 coordinates. Makes sense? Example 7. So example 7 says, does everyone have that? Is this point on the unit circle? How can you prove if something's on the unit circle? X squared plus y squared equals 1. So if you plug it in and you get it equal to 1, it's on the unit circle. Is that true? No, it looks really nice. Kind of true. If I want to round it, maybe it could be true, but it's not true. Okay? So it's not. No. Is B on the unit circle? Yeah. Why? Because it's physically on the unit circle when we fill it in. But we... This square plus this square and it'll equal 1, right? Okay, determine the missing coordinate for each point on the unit circle. So I want you to do point A and point B, please. It wants it in quadrant 2. So what's x going to have to be? Negative. This one is Now this one, I just want to specify that remember from grade 10, see, this remember from grade 10 thing keeps coming up. So say I gave you 2 over 25, let's say, okay? And they gave it to you like this as a square root, and they asked you to reduce it. What could you do? Yeah. You're thinking conjugate, but nope, you're close. Yeah, you can split this root up. You can go root 2 over root 25. That's what they taught you in grade 10. So you can actually write this as root 2 over 5. So the radical can be split. Okay? So we're going to square root this one. When we square root it, we get plus or minus. And we're going to get y equals square root 35 over 6. But it's in quadrant 4 and it's y. So in quadrant 4, y, what is it? Negative. Okay? The homework is at the bottom, but we're going to start the next lesson. So 4.3 primary trig ratios. So we have sine, we have cos, we have tan, and then we have the reciprocal trig ratios of cosecant, secant, and cotan. Now, some people came up with acronyms last year to remember sine, cos, and tan. So if you want to use them, you can. Sine theta is y over r. And what they remembered it as is sine your, I know that's not right, it's sin, but whatever. Sine your resume. It is what it is. You can like it or not. You can use it or not. But you'll probably be saying them. Okay, and then you have cos theta over x over r. Cook extra rice. Now this is even stupid, like more stupid because, well, you have still extra like that, but whatever. Good. Extra rice. And then this one's probably the worst because it makes absolutely no sense, but up to you if you want to remember it. Tan your Xbox. I think is the only thing they come up with X. Tan your xylophone. I don't know. Tune your xylophone, but then it doesn't start with tan. The thing's tan. So that was what. I know. Trust me, I didn't make them up. You can use them or not. That was scaring me, so I was glad that we didn't have a body part that started with X. Didn't feel like Googling it. You could look up, I don't know. You could look up a body part if you'd like. Xiphoid process. I don't know. Is it with a Z? I think it's with a Z. Tan your X-ray. I don't know. Got nothing.
No, it's an X.
It is.
Xiphoid process.
Xiphoid. Okay, tan your xiphoid process if you'd like. There. Oh gosh. Either of those are options. You could tan a xylophone if you'd like. I don't even think you can actually tan your xiphoid process. What is your xiphoid process? You could try to. You probably have to rip your skin off first and then tan the bone, but whatever. It's getting a little vicious, but it's up to you. I'm going to leave my xiphoid process not tanned, but if you would like to, please go for it. Okay. So remember, sine, cos, and tan have the reciprocal functions. So cosecant goes with sine, secant goes with cos, cotan goes with tan. Cotan and tan make sense. Cotan, tan. They both share tan. The other two, just C doesn't go with S and S doesn't go with C. That's how I remember it. So if it's sine, it's cosecant, cos, secant. C and S, C and S. Okay? They're literally just the reverses. So if you remember your 3 primary trigonometric ratios, then you can write out the reciprocals and just write the y and x is flipped, right? Because they're reciprocals. Reciprocal just means flipped, right? So if this one is sine y over r, then cosecant is r over y. Cos is x over r, so secant is r over x. Tan is y over x, so cotan is x over y. Okay? Now, cast rules, we remember this. Cast, cos, all, sine, tan, it's where those trig ratios are positive, right? Starts over here and works your way around. So, cos is positive here. Then indirectly, what else is positive here? Secant. All of them are positive here. All 6 ratios, the primary and the reciprocal. Sine is positive here, so also is cosecant because it's its buddy. And then tan, and then cotan because it's its buddy. Okay? Okay. So, example 1. Given the following point on the terminal arm of some rotational angle, find the exact value for all 6 trig ratios. So they're asking us for the actual trig ratios. They're asking us for cos, sine, tan, cotan, cosecant, secant. Okay? So the very first thing you do whenever you get a point in trig is I'd plot it. Because this is an x and a y. And for primary trig ratios, I need x, y, and r. Right now I don't have r. R is the radius. The radius you can find once you plot the point. So we plot our point. We have -2, -6. So we have ourselves a little triangle. This is -2. This is -6. So this is y. This is x. And then this is the radius because it's from center to edge, right? How could we find it? Pythagorean theorem, because it's on a 90-degree triangle. You're correct. It's on a right triangle. Now, whenever answering these questions, they're always going to have them in exact values, so you're going to keep it as a reduced radical at the very least. So you're going to get 4 plus 36 equals r squared. 40 equals r squared. And then you square root it. Whenever you take the square root, you take the positive or negative. The catch on this one, so if they give you partial points, you'd actually have to know what quadrant it is to know what sign it is, correct? But radius is a length. Radius is a distance. It's a length. Can lengths ever be negative? No. So your radius is always positive. Can I reduce this 40 to 4 and 10? So the 4 comes out and it becomes a 2. So this is grade 10 again. See, grade 10, it comes back a lot. So 2 root 10 equals r. And now we can state all of our trig ratios. So sine theta. If you are writing a trig ratio and you're forgetting that little theta symbol and you're just writing sine equals something, you're actually wrong. Because I need the trig ratio in order to find this angle, correct? Technically. Getting the trig ratios will get you this angle in the end if you want to. But if you don't have the angle, the theta symbol, you actually have nothing to find. You've solved the whole thing. Then you're saying, so sine is your resume, so y over r, so it's going to be -6 over 2 root 10. So you're saying if you drop this theta off, you're saying sine equals that. Is that true? No, sine theta equals that. So you need these theta symbols. So many people drop them off, drives me crazy. Don't do that. It's actually wrong. Now, this is correct, but they usually rationalize their denominator. So you're going to have to multiply by root 10 over root 10. And if you do it to the bottom and the top, because root 10 and root 10 is just 1 when you multiply them, so you're not changing it. So on the top, I'm going to get -6 root 10 over, what's root 10 times root 10? 10. And 2 times 10 is 20. Because remember, you always multiply the numbers in front of the radicals together and the radicals together. That's what you do. You got that in grade 10. So 2 times 1 is 2. Root 10 times root 10 is 10, so it's 20. And then this can reduce to negative 3 root 10 over 10. Now some people will say, well, cosecant is just a flip of that. Cosecant is just a flip of that. But why would I flip this? Then I'm going to have to rationalize again. So if I'm going to flip the cosecant, I'm going to end up flipping this original one. I'm not going to flip the end of sign. I'm going to have to rationalize again. So cosecant theta, instead of y over r, it's r over y. So we get 2 root 10 over y, which is negative 6, which I can reduce to root 10 over negative 3, or negative root 10 over 3, or negative root 10 over 3. As long as there's only one negative, doesn't matter where that negative is. It's the same thing. Sine, I already did. Cos is extra right, so it's x over r, and x is negative 2. R is 2 root 10. I'm going to reduce these first and then rationalize it. So I'm going to get negative 1 over root 10, multiply by root 10, and I get negative root 10 over 10. Because this box is not leaving me very much room. Secant, just draw it all over the place. Secant theta, instead of cook extra rice, it's going to be rice extra. So r over x. So 2 root 10 over negative 2. These cancel. So you could write it as root 10 over negative 1, but you won't ever see it that way. It's just going to be negative root 10. Tan your X box or tan your xiphoid process. I like it. Is going to be y over x. So it's going to be negative 6 over negative 2, which is 3, which is awesome because you don't have to rationalize it. And then cotan theta is negative 2 over negative 6, which is 1/3, which is the reciprocal, technically, of this. Remember, these are reciprocal identities, so their answers are going to be reciprocals of each other, right? So I'm just going to let you do that, but I want you to do 2 and 3, and then you can work on your other homework. Do 2 and 3. I'll write them on the board as well so you can check them, and then you can do your homework. 2 and 3.